Hi, 8th graders. I'm just going to walk you through the first question on the HSA practice test, and I will have other videos for other questions as well. So this is the one that we talked about in class. So you'll notice again that it has a bunch of background information on the left-hand side. I would encourage you to read that information. It can help you out. So I'm going to use a line reader just to help me keep track of what line I'm at. So I don't know anything about electromagnetism. However, it does give me some information to help me understand what's going on. So as a bar magnet passes by a coil of wire, the needle on the ammeter moves. So this is the bar magnet, this is the coil of wire, and this is the ammeter. An ammeter measures the electric current in amperes flowing in a closed circuit. A positive or negative measurement on the ammeter indicates the direction of the current flow. So what's important to note here is that we're measuring the electric current using this little machine. If you don't know what electric current is, that's fine. It's okay. Two wires from an ammeter are connected to opposite ends of a coil. Here's one, here's the other. The needle in the ammeter jumps to the left when a bar magnet moves near the coil. Animation 1 shows the movement of the ammeter needle. Click on the gray arrow to start the animation. So they're moving the magnet, and then the needle is jumping to the left. So that's how we know that a current is flowing through. So, Table 1 lists several materials and whether each material is magnetic and conducts electricity. So, aluminum does not attract magnets, but it does conduct electricity. Iron does both. Nickel does both. Plastic does not attract magnets, and it does not conduct electricity. And now we're going to set up an experiment to provide an explanation of what causes the ammeter needle to move. So, here's our experiment. So first of all, it says, select inputs to design a controlled experiment to determine how each coil material affects the movement of the ammeter needle. Again, this is your key phrase. Determine how each coil material affects the movement of the ammeter needle. So the coil material comes before the word affect. That means that it's the cause that's going to cause something else to happen. So that is the independent variable, the thing that we want to change. What it's going to affect or have an effect on is the movement of the ammeter needle, which again measures current. So that is going to be our dependent variable, the data that we're going to collect. So what comes before effect is the independent variable. What comes after the word effect is the dependent variable. You may run up to 4 trials. If you would like to delete a trial, click on the trash can icon next to the row of data you'd like to delete and generate new data. Coil length is measured in centimeters. So I'm going to delete these because I ran them earlier. And we know that we want to change the coil material because that's our independent variable. So this is the only thing that we're going to be concerned with changing at this point. We're going to leave everything else the same for all of our trials. And as a reminder, since you can only run 4 trials and there's 4 different materials, you can only run 1 trial per material. So for aluminum, we're just going to hit run and see what happens. Absolutely nothing happened. There was no maximum current and nothing happened in the simulation. That means that we didn't get any kind of current going whatsoever. So we know from the other side over here that when we run this animation, the current only appears when the bar magnet is moving. So we do need to move that during our experiment to actually test out the materials. If we just go through and test out each of the different materials as is, which you would find out if you did this, you would see that you don't get a current at all. And the whole point is we're supposed to determine how each coil material affects the movement of the ammeter needle. None of them made the needle move in this experiment. And the reason why is because our bar magnet was not moving. So again, in the animation, you have to be moving this bar magnet in order for the current to form. They don't tell you that. They only tell you that in the reading. So it's important to go through and look at the reading. So we're going to delete all of these trials because none of them worked. And we're going to change the bar magnet speed to fast. And now we're going to go through the 4 different materials again. So now the experiment actually worked. You saw the needle jump. We were able to measure an electric current. Now we're going to do iron. We're going to keep everything else the same, run the trial. Okay, and then we're going to do the same thing with nickel. Keep everything the same because they're constants and run the trial. And then lastly with plastic. Okay, so now we have data that we can actually look at. So in order to figure out how each coil material affects the movement of the ammeter needle, we can see that aluminum, iron, and nickel all gave us a current, but plastic did not. So we're going to scroll down then. We answered that question already because we now have our 4 trials. We have our 4 different coil materials, and we know how it affects the movement of the ammeter needle. Aluminum affects it the most, and plastic affects it the least. Next one is this. So using a simulation, design and run a second experiment to determine how the motion of the magnet affects the movement of the ammeter needle. So again, now it's the motion of the magnet affects the movement of the ammeter needle. So the only thing that we're going to be changing now is the motion of the magnet. And the thing that we are measuring is the movement of the needle. So we're going to leave coil material the same, and we're only going to be changing, we're going to leave coil length the same. The only thing we're going to change is this, the bar magnet speed, because it's the motion of the magnet. Okay, so we're just going to use aluminum because we know that aluminum gave us the best result on the last one. So we're going to leave it as aluminum here, and then we're going to change the bar magnet speed. And they give us up to 4 trials. So bar magnet speed, we're going to leave as none for now. We're just going to run it. So nothing happened. So the bar magnet didn't move and it didn't give us any current. Now we're going to do the bar magnet fast and leave everything else the same because those are constants and run the trial. So when we move it quickly, we get a current going. And then lastly, we have one more option to run it slow. So run the trial again. And then we collected our data. We actually only need 3 trials for this one because there's only 3 options for us to go through. And we did all 3 of them. Again, remember that on the HSA test, you can only do 1 trial for these experiments. You do not need to do 3 trials like we do in class. So that's our answer for this one. Oh, and then lastly, I'd already striked these out. So I'm going to pause.